moving on here with 9.8, it is just because I feel like I shouldn't have to say this, or by my saying this, it damages your opinion of the material we have here. Here in Chapter 9, because again, I felt so strongly about this, I actually put a warning video first here with all of the chapter's content that really from here on out we are shifting from the kinds of chapters we saw where we do big heavy lifting with chapters 1 through 8 essentially. And now we're going to start doing a lot more of this stuff where we're sprinkling in little pieces, little pieces, little pieces, because they're important to the way these concepts are going to impact your developments in your careers. It's just that with the size of the examples we have, they, like, the example itself seems like it was shoehorned in here because frankly it is. So this explainer portion is going to be longer than the actual explainer for what's happening here in 9.8 dynamic memory allocation, which is on page 531, it looks like. The real takeaway here is two keywords that are available to you to be able to use: new and delete. So if we scroll down just a little bit here, it's whatever page this is on, 531. We have iPointer equals new int array of size 100. So what's happening here is we're saying we are declaring iPointer is the name of our variable. Our variable is going to be a new array. And we need that new in order for delete to work. Now, let's say that iPointer does some small portion of work for us. You know, it's got the 100 highest scores for this week, so we can, you know, send a coupon for Chinooks or whatever. It's got the 100 highest, grossing salespeople for Chevy, so we're going to send them a coupon for a steak restaurant or whatever it is that we would do. Do people still buy cars that way anymore? I guess I don't know. So we've got this new int array that we have created, and we have populated it, and we've done whatever work that we're going to do with it. Now, the problem or the challenge here is that when C++ began running this particular application, it went through and it looked at what it had to do to allocate all of the storage that was necessary. And the longer this runs, though, that's outside of C++'s ability to guess how many times am I going to actually call to something that uses iPointer, IPTR, the array here. So instead of just allowing 100 integer arrays allocation to stay there and then be called again and again and again and again, so that I have 1 and 2 and 3 and 4 or 100 allocations for a 100 integer array, we have the idea of delete. It's that when we are done with whatever job it is that iPointer was created to do, that we deallocate all of that space so that it can be used again by C++ in the run of the greater program. If you choose, or if you attempt rather, to delete an array that did not have new in its declaration, you cannot do so. So the idea of delete requires that it brings the idea of new with it. But this can lead to substantial overhead and substantial storage savings. Again, in the relatively small scope of what we're doing, no. It's not as important as it's going to be when you are doing, a much larger development someplace else. So it's worth knowing that they're here, and again, germinate that stuff, and know that it's coming someplace else down the line.